application level security. You might be able to lock down everything else and make all those things fully secure, but here you're building an application or APIs that you have kind of opened up, and you need to think like a James Bond villain is what I'm saying basically. But for those of us Java developers that are the good guys, there is Spring Security. In this video, you will learn what Spring Security is really all about and why you might want to consider using it for securing your web applications. Here's the problem with security. As application developers, we just don't want to do it. It's not fun, right? We like building new things and features, something that's directly user impactful. Hey, look at this cool new feature. That's fun. But security is not so fun. So what ends up happening is security is usually an afterthought. More so because it's not only stopping you from creating something new for your users, it's also something that could potentially cause trouble or frustration to your users. So why do we have to do this? My web server has security built in. Why should I, as an application developer, need to deal with security? Well, here's the thing. All the operating system level security, the JVM level security, the app server security, that's all kind of handled for you already. What we're talking about here is application level security. You might be able to lock down everything else and make all those things fully secure, but here you're building an application or APIs that you have kind of opened up and it allows users to use. So for most applications, you have to implement security at an application level. You need to think of what are the things that your users can do in the context of your application. What's the functionality that you want to allow and to whom? What's the kind of data that you want to expose and to whom? That's the kind of security we're talking about here. And the biggest thing that makes security a challenge is this. Security threats are constantly evolving and morphing. This is kind of like the biggest reason why it's so hard to keep up with security. What you need is for security to be maintained by a bunch of security nerds who spend all their waking hours thinking about how applications can be made more secure and how to prevent hackers from defeating the security of your application. Because guess what? There are certain smart hackers spending all their waking hours thinking about how they can hack into your application. Basically, what you need is not to handle security yourself, but to hire like a watchman or a security guard. Say you want to safeguard a particular building to allow only the right people to enter. So you decide to hire a watchman or a security guard who stands in front and intercepts any visitors. Anytime somebody wants to enter, the security guard asks them two quintessential questions asked by security guards over the years all over the world. Who are you and what do you want? Spring Security is like hiring this full-time security guard who sits in front of your web application and examines every request to your application and asks these two basic questions. Who is this request from and what do they want? So Spring Security is an application framework that helps you do application level security. What does that mean? A bunch of things actually. You can say, hey Spring Security, give me login and logout functionality. Or you can say, hey Spring Security, I want only these two URLs to be publicly accessible. These two URLs of my application, I want only logged in users to access. This particular URL, I want it accessible only by someone who is not only logged in, but also has admin access. You know, this kind of stuff is referred to as application security. This is access control specific to your application. Now, how does it do it? Spring Security lets you configure it to your application's needs so you can have it do the right things that you want. Because you see, the need for security itself is very common, but how that security needs to be achieved isn't common. It varies widely between applications. For this reason, Spring Security has been built to have a lot of flexibility, and it is very, very, very likely to be able to handle your particular security needs. Another benefit of Spring Security is that it can handle a lot of the common security vulnerabilities right out of the box. Just by adding Spring Security to your app, you get protection from a bunch of vulnerabilities like session fixation, link jacking, cross-site request forgery, and all that stuff. Spring Security handles all those vulnerabilities, so you don't have to. The other benefit of Spring Security is that it's very widely adopted in the industry. Although it's kind of like a double-edged sword. Since it's so widely adopted, people are probably constantly trying to find vulnerabilities in it. However, considering the usage, even if there is a vulnerability found, I'm pretty sure it'll immediately get patched. After all, you cannot achieve security based on secrecy or hiding your vulnerabilities. You get effective security only by removing your vulnerabilities and having nothing exploitable there to begin with. Here are some of the things you can do with Spring Security. You can do username password authentication. You can have your application ask for username and password before letting people authenticate. You can also do a bunch of single sign-on stuff like Okta and LDAP. You have app-level authorization, which goes in addition to authentication. If you don't know what they are, check out the next video in the series. You can also do intra-app authorization using technologies like OAuth. You can basically have applications authorized with other applications. You can also do microservice security, which is basically when you have a bunch of microservices that are talking to each other, how do you make sure that one microservice exposes certain APIs only for this one other microservice and not for this other microservice? Well, you can handle all those things. And then you also have method level security, where you're basically securing not just URLs and APIs, you're securing methods and objects in your code, which is much more granular and much more powerful. As you can see, Spring Security can be pretty versatile and powerful. In order to learn and use Spring Security effectively, there are 5 core terms and concepts that you'll need to understand as they are repeated over and over in your Spring Security journey. Watch this video next to learn those 5 terms and really understand what they mean. I'll see you there.
Step into Lead Studio, the platform for agencies and enterprises. Kick off projects in a word.
In this video, you will learn 5 key concepts and terms associated with Spring Security that you'll really need to know. When you learn Spring Security, you'll encounter these core terms and concepts over and over. So in this video, I'll break these terms down and explain them for you so that you know exactly what they mean. The first 2 terms are so commonly used in the context of security that it's kind of unlikely that you haven't heard them before. They are authentication and authorization. To understand authentication and authorization, you also need to understand the difference between the two. So let's tackle these 2 terms together. What is authentication and what is authorization? I usually like to imagine Spring Security as being this watchman or security guard in front of your web application and stopping every request going in. The security guard typically asks 2 questions. Who are you and what do you want? And it is your job to answer the security guard those 2 questions if you're requesting something from your web application. You answer the first question, who are you, by telling the guard who you are. Note that just telling the guard isn't enough here. You also have to prove it. Proof of who you are is usually by providing some kind of ID, something that only you can provide and an impersonator can't. And then you answer the second question, what do you want, by just stating what you want or what you would like to do. You don't need to provide any proof for the second part because there's really no point in anyone lying here. You can only possibly get what you ask for. So answering the first question, who are you, is what's called authentication. Most web applications have some representation of an ID. You open like a Facebook or LinkedIn, these sites usually have an ID or an account in their system that kind of uniquely corresponds to you. So when you access the site, you need to tell it which of those millions of accounts in the system that it has that corresponds to you. After you tell it which account is associated with you, you also need to prove to the application that it is indeed you. A common way this is done is by providing your user ID and password. It's a way for you to say, hey application, here is the secret password that I told you when I created the account. Here is the same secret password again to prove that it is indeed me. This type of authentication is called knowledge-based authentication. The authentication is... So answering the first question, who are you, is what's called authentication. Most web applications have some representation of an ID. You open like a Facebook or LinkedIn, these sites usually have an ID or an account in their system that kind of uniquely corresponds to you. So when you access the site, you need to tell it which of those millions of accounts in the system that it has that corresponds to you. After you tell it which account is associated with you, you also need to prove to the application that it is indeed you. A common way this is done is by providing your user ID and password. It's a way for you to say, hey application, here is the secret password that I told you when I created the account. Here is the same secret password again to prove that it is indeed me. This type of authentication is called knowledge-based authentication. The authentication is based on knowledge that you have. This can be a password or a PIN code or an answer to a personal question or some other secret that you know. The biggest advantage of knowledge-based authentication is that it's simple and it's pretty effective for the most part. However, it does come with a disadvantage. If somebody steals your password or somehow finds out what your password is, they can impersonate as you. All that uniquely identifies you is this single piece of string value. There are, however, other authentication mechanisms in place though, like possession-based authentication. This is, for example, when an app sends you a text message and asks you to enter it. It's trying to identify if you are in possession of something that the real user should be in possession of, in this case, your phone, because phones are slightly harder to steal than passwords. Other examples of possession-based authentication include keycards or badges that you use to swipe and enter buildings. The idea is that only the real you can possibly be in possession of this card. So if your card is used to swipe to get into a building, it's likely to be you who's trying to enter that building. Some apps do a combination of knowledge-based and possession-based authentication using what's referred to as multi-factor authentication. Enter your password and then verify your text message, right? Two-factor authentication, multi-factor authentication. So that's authentication, basically answering the question, who are you? Of course, with proof that you are actually who you say you are. Now let's move on to authorization. This is the security guard examining what you want and then deciding if you're allowed to do that. In other words, it's answering the question, can this user do what they're trying to do? It's a kind of like a yes or a no answer for a given operation. The user might be able to do one particular operation and they may not be able to do another operation. Let me give you an example. Consider a retail store application. Everyone who works in the store can log into the application and use it. They can authenticate with their user ID and password. But once they've authenticated, what each person can do in the application really depends on who that user is. A store clerk, for example, can probably access point of sale functionality or check if something is in stock. A department manager can probably see how his or her particular department is doing. And the store manager can see everything across the store, across all departments. So every time anybody accesses anything in the application, the app is doing this binary yes or no decision to arrive at an answer to the question, should this user be allowed to do this operation? It also has mechanisms in place to block the user from doing any operation that they're not allowed to do. This allow yes or no decision, depending on who the user is and what they're trying to do, is called authorization. So in a way, for authorization, you kind of need authentication first. You need to know who the user is first before being able to make a decision on whether or not that particular user can do something or not. So this is authentication and authorization, and the fundamental difference between them. These two terms are not specific to Spring Security, by the way. They're widely used in the software space in general, and they mean kind of the same thing. All right, concept number 3. This is also a Spring Security concept, but it's used in some other frameworks as well. The term is principle. We've talked about how authentication is the process of identifying a person trying to access the application. The principle is the person you've identified through the process of authentication. In other words, a principal is the currently logged in user. A principal is also a person I really used to hate in primary school, but that's a different story. In the context of Spring Security, it is this currently logged in user. It is that unique information or account in the system that you tie to a specific person in the context of the application. Once you authenticate with any application, say by giving your user ID and password, the application establishes the principle and it remembers it. This is the reason why you authenticate with an application only once and you don't need to enter your user ID or password for like every request or page load, because that would be really annoying. Yeah, that's because app remembers the principal as the currently logged in user in the context of the application. This term in the context of the application is super important. There may not be a one-to-one mapping between a user or a human being and a principal. Okay? Take Google for example. A single person can create multiple Google accounts. So Google has multiple email IDs or accounts sitting in the system that actually correspond to one user. When the user logs into Google, let's say they're using the credentials of account A, then the principal corresponds to account A. There is a currently logged in user which corresponds to account A. Then the user can switch their current login to account B and the principal corresponds to account B. So the best way to think of a principal is as the currently logged in user or currently logged in account. Okay, on to the fourth term and the fourth concept. We've looked at how authentication happens, knowledge-based or possession-based or whatever else. Now, how does authorization happen? How does the application decide whether or not to allow a particular access? Well, that has to be coded in beforehand, obviously. The application owner or maintainer should have specified beforehand, okay, user is this, allow them to use only these actions. User is this, allow them only these other actions. So it's like a bunch of permissions that are allowed for a given user. Application will allow or authorize them to do it only if the user has been granted a